Hi there, this is Ms. Page, and in this lesson we are going to talk about how to graph a polynomial function from the factored form of the function. And the two things that we're going to worry about, because we're really creating more of a sketch than a full accurate graph, the two things that we're going to use to create the graph that we're going to be doing is the end behavior and the zeros. And one of the things that we have to realize is there are two things that we're going to need in order to figure out our end behavior. So that's what this is saying here. The end behavior is determined by two characteristics. One is the degree of the function, which actually is the highest power of the variable, and whether that is an even number or an odd number. And what we're looking at then is from factored form, we don't actually see that first term, which gives us the degree directly. So we are going to learn how to calculate the first term without having to multiply everything out. The next thing that we need to use is the sign of that first term, its coefficient. So the leading coefficient would be the multiplying factor on that first term, and we have to know, is it positive or is it negative, because that is going to tell us whether we have an x-axis reflection or we don't. And so let's take a look at what's next. All right, so the degree of the polynomial function, if it's odd, so an odd degree means it's like a cubic, or could be a linear. Here we see linear, here's our cubic, here's a fifth power, which is called a quintic function sometimes. And if our degree is odd, what we need to realize is that that's like our cubic, so the end behavior goes opposite directions, as we see here. So one end goes to positive infinity, the other end goes to negative infinity for a odd degree. These are both cubics in this case. And which end goes up has to do with the sign of the leading coefficient. So if the leading coefficient is a positive number, then our right end goes to positive infinity. If our leading coefficient is a negative number, then our right end goes to negative infinity. It's kind of the reverse of what we were using to figure out whether A was positive 1 or negative 1 in the previous lesson. In that lesson, we had the graph, so we could see the end behavior. And then what we wanted to do was write the function. And we had to know, well, would the A value be positive 1 or negative 1? Here, we are going to have the factored form of the function. So we need to know, all right, what is our end behavior? Where does the right end go? Does it go up? Does it go down? And do both ends go up or do both ends go down? So your odd degrees, one goes up and one goes down. And the right end, whether it goes up or down, is going to match the infinity sign on the leading coefficient. So if the leading coefficient is positive, that right end goes to positive infinity. If the leading coefficient is negative, then that right end is going to go to negative infinity. With the even degrees, like we see here, so now what we have is an even degree, such as x squared, x to the fourth, x to the sixth. Our x to the fourth, that's our quartics that we've dealt with, but all even degrees work the same way here for polynomial functions. So here we're seeing we have an even highest power of x. Here we have a positive leading coefficient, and that means that our right end goes up. But in an even degree, both ends go the same direction. Like in your parabola for your quadratic, both ends go the same direction. Well, that's true for all even degreed polynomial functions. So in this case, we're looking at a positive leading coefficient means the right end goes to positive infinity. Because it's an even degree, so does the left end. So they both go to positive infinity. With a negative leading coefficient then, they're both going to go to negative infinity. There's our negative on our 3, and they're both going to go down because we have an even degree and a negative coefficient. Even degree, both ends go the same direction. Negative means they both go to negative infinity. All right. So this is kind of giving us a step-by-step process we can use to create the graph from our factored form. So we're going to learn how to calculate the first term of what we call the standard form, like if it was all multiplied out. And this is describing how we're going to do that. We're going to multiply any monomial factor and all the variable terms from other factors such as binomials and maybe trinomials sometimes, things like that. So what we're looking at here then is, we're going to determine our end behavior using that first term. So if it's an even degree or an odd degree, and if it's a negative or a positive coefficient. Then we are going to find the zeros of the function, and technically we could do that first, quite honestly, but we'll need to know what our zeros are and whether there's any multiplicity with repeated factors, and then we'll sketch a smooth curve. So you might want to add into your notes here, include multiplicity. All right, let's take a look at a problem. So it says for each function, we have a few parts. We want to state the end behavior. So that means to very clearly write it out using our proper notation. We're to state the exact values of real zeros. So without doing any, so if we have a square root, like an irrational one of the square root of 2, then we want to state it as a square root of 2 and only get a decimal approximation for graphing purposes. It wants us to include any multiplicity, so make it clear, like if 2 repeats and has a multiplicity of 2, we have to say that. And then we also, of course, need to make sure we do a sketch of the graph. All right, so here is our function. So here the first thing we're going to talk about is how do we figure out the first term of this in its standard form? Like if it was all multiplied out, what would be the first term in its standard form? And that first term is found by taking the monomial factor of x times all of the variable factors of the binomials. And this one we have to take as a negative x. So we're going to take x times negative 1x, and that's going to give us negative 1x cubed. All right, so we have x cubed. That's an odd number. That means we have an odd degree. And an odd degree means that our end behavior, one end is going to go up and one end is going to go down. And the right end is going to match the sign of our leading coefficient. So that means as x goes to positive infinity, our right end, our function values, f of x values, are going to go to negative infinity. Fix that infinity there. There we go. And that means because we're odd, then our left end, as x goes to negative infinity, our function values will have to go to positive infinity, like so. All right, so that's part A, done. Now part B, we want to figure out what our zeros are. So for my zeros, I am going to use my zero product property. So remember, zeros are found when our y, which is our f of x, is 0. So I'm going to rewrite the function here, and I would recommend you do that in your notes also. So we let y be 0. And remember that any time we create a structure like this, which we call a product of factors equals 0, the next step is going to be used to use the zero product property. So if this product of factors equals 0, then either the factor of x has to be 0, or the factor of x minus 4 has to be 0, or the factor of 1 minus x has to be 0. So now this one is already equal x by itself, so that means that 0 is actually one of our zeros. This one we'd have to add 4 to both sides, which would give us x equals 4. So 4 is a 0. On this one, because the x is negative, personally, I would add x to both sides. And that would give me 1 equals x, so then 1 is a 0. So for part B, my zeros from least to greatest would be 0, 1, and 4. And this is a good way to write them because that's the way we have to graph them. And so we make sure that we put everything in the correct positions a little bit. Less likely to make a mistake that way. All right, so now we are going to draw our graph. So we need our axes. So again, we'll be estimating maximums and minimums between zeros. We have no multiplicity to worry about this time because all the zeros were different. And I just have to make sure that I can get over to 4. So my x-axis, my y-axis, this would be, so I have a 0 of 0, I have a 0 of 1, and I have a 0 of 4 right there. And my end behavior, remember, my left end is going up to positive infinity. My right end is going down to negative infinity. It's supposed to be a 2. There we go. So I'm going to start up here, sweep through my zeros, put my arrows on the ends, and that creates my graph and finishes all parts of the problem. All right, let's take a look at another one. All right, so here is the function that we are going to be working with. Now, this one right here, notice that x plus 5 is to the power of 2 on the outside. So what that actually means, and there are a couple of different ways that you can look at this, but when we go to find our first term, it does matter that that's to the second power. That means we have 2 factors of x plus 5. So that first term that we need to help figure out our end behavior, our monomial factor is just a 1, so I can use it if I want to, but don't have to because anything times 1 is itself. And then we have an x, a 3x, and a 2x. We multiply all those together. So we have the 1 times x again. So that's why that x plus 5 to the second power matters, because we need that x twice. And then we need the 3x, and then we need the 2x. And then that's going to give us 6x to the 4th power. So our exponent is even, so that means that we have an even degree, so both of our ends on our end behavior go the same direction with our evens, and this is a positive 6, so that means that the right end goes to positive infinity. Because it's an even degree, the left end will also go to positive infinity. So as x goes to negative infinity, our function values will go to positive infinity. As x goes to positive infinity, the right end, the function values go to positive infinity. So that takes care of the first part. Second part, we want our zeros. So what we have here is 4 factors because that x plus 5 was squared. So for our zeros, we know that y, which is our f of x, would be 0. So we get 0 equals x plus 5 times the second x plus 5 times the 3x minus 2 times the 2x plus 3. And then our zero product property says either x plus 5 equals 0 or x plus 5 equals 0 again, or 3x minus 2 equals 0, or 2x plus 3 equals 0. So here we'd subtract 5, and that gives us x equals negative 5. Same thing here. This one, make sure you're careful here. Use your reverse order of operations, so undo the subtraction first, which gives you 3x equals 2. Then undo the multiplication, dividing by 3, which is going to give you x equals 2/3. And then for this one, I'm going to bring it up here because I'm kind of out of room here. Here we would subtract 3 first, undoing the addition, and then divide by 2, which gives us x equals negative 3 over 2, which is negative 1.5. All right, so our zeros then are from least to greatest, negative 5, negative 5, that's our multiplicity, and then our negative 1.5, and then our positive 2/3. Kind of need some space here, so. All right. So now what I'm looking at is creating my graph. So I need to draw my axes and make sure I can graph all of those on my x-axis. Middle actually I think will be fine. So we're at negative 5. 1, 2, 3, 4, 5. So there, and there's multiplicity there. So I want to forget about that. Negative 1.5 would be right here between negative 1 and negative 2. And then 2/3 would be there. 2/3 of the way between 0 and 1. All right, in behavior, remember, both ends are going up to positive infinity. Now remember, with the multiplicity here, as we come down, this is going to be then a relative minimum because we're coming at it from above. So that's going to be a minimum. And then everything else is a regular old 0 to create our graph and finish the problem. All right, let's try, I think there's a practice problem next. Yep, so pause the video, give this one a try. All right, let's take a look at what we should have. So in this case, our first term is negative 2x cubed. So it's an odd degree, so the ends go opposite directions. The leading coefficient is a negative number, so the right end goes to negative infinity. Then our zeros, we get our 0 equals our product of factors. So negative 2x equals 0. Dividing by negative 2 gives us x equals 0. This one gives us x equals 5 when we add. This one we subtract, and it gives x equals negative 3. And then this creates our graph. There's no multiplicity in this one. All right, let's take a look at what's next. All right, another example for us to do together here. All right, so here is the function that we are going to graph. So with this one, the first term, so again, our monomial is just a 1 there. And then we have x squared, and we have negative 1x squared. So we take our 1 times x squared times a negative 1x squared. And that would give us negative 1x to the 4th power. So our degree is even, which means our ends go the same direction, and our leading coefficient is negative, which means both ends go to negative infinity. So as x goes to negative infinity, that's the left end, our function values f of x go to negative infinity. And as x goes to positive infinity, the right end, the function values go to negative infinity, like so. All right, so now we're going to take a look at our zeros. So our zeros here, again, we would have f of x being 0, so we get 0 equals x squared minus 20 times 9 minus x squared. So once again, any time that we create a product of factors equals 0, the next step is to use the zero product property. So either x squared minus 20 equals 0, or 9 minus x squared equals 0. All right, with this one, if I add 20 to both sides, I get x squared equals 20. Then using my square root property, take the square root of both sides. Remember, we get plus or minus the square root of 20. And that's going to give us x either equals negative square root of 20 or positive square root of 20, both of which we can simplify because they have a perfect square factor of 4. So this is negative 2 root 5 and positive 2 root 5. All right, here, personally, I would add x squared to both sides, which now gives me either 9 equals x squared or x squared equals 9, whichever you prefer. And taking the square root of, sorry about that, trying to get rid of that, taking the square root of both sides, we get x either equals negative 3 or positive 3. So remember that your instructions said that for part B, you want the exact values of the zeros. And so here, we want to make sure that we use the positive and negative 2 root 5. Those are your exact values. So for your zeros, we have negative 2 root 5, negative 3, positive 3 actually would be next, and then positive 2 root 5. So there's our zeros, like so. For graphing purposes, though, we're going to need to approximate the square root of 20. So I'd be looking again, remember, at, so square root of 20, 20 is between 25 and 16. So the square root of 20 is between 4 and 5. The difference between 25 and 20 is 5. The difference between 20 and 16 is 4. So it's a little closer to the square root of 16. It's a little closer to the 4 than it is to the 5. So I would probably say it is about 4.4 would be a good approximation for the square root of 20. And so now that would give me a positive and a negative square root over here. So about negative 4.4 and positive 4.4, like so, just to keep for reference. So now I'm going to draw in my graph, my scale, or my axes rather, on my graph. And so I'm going to put this in the middle, y-axis in the middle. And so now what I'm looking at is, all right, so about negative 4.4, 1, 2, 3, 4 would be right about there. Negative 3 there, positive 3, and positive 4.4, right around in there. And our ends, remember, are both going to negative infinity. So that, and then we have no multiplicity to worry about. So we just start down here, for example, move through, nice smooth curve, put our arrows on the ends. All right, let's see what's next. All right, we have a practice. Here you can pause, give this one a try. All right, let's see what we're supposed to have gotten. So here our first term is negative 2x cubed. Our x minus 3 is quantity squared, so that gives us 2 factors, which gives us 2 zeros of 3. This one we should subtract 5 and then divide by 2, which gives us negative 5 halves, or negative 2 1/2. And so this is written with the multiplicity times of 2 notation. You could also just write 3 twice, like I have been doing. Both notations are fine. And so notice at 3, it ends up being a relative maximum. Our end behavior, because our leading coefficient is negative, that right end has to go to negative infinity to match that sign. Because our degree is 3, which is an odd number, the other end goes in the opposite direction. So the left end goes up, the right end goes down, like in this case. All right, let's try another one. Here's another practice problem. Give this one a try. All right, let's see what we should get here. So with this one, our first term is negative x to the 4th. So x to the 4th means both ends go the same direction. The negative, which means negative 1, the negative leading coefficient means they both go to negative infinity. So that's what we see here and what we see here and here. Here we have x squared equals 0. And another way that you can do this, if you weren't sure, is instead of doing it like this and realizing you're going to get 2 and using your square root property, just rewrite it like this. And then you have your negative 1x equals 0, or your positive x equals 0. And this dividing by negative 1 still gives you x equals 0. So you get 0 twice, and then this gives you positive and negative square root of 8, which simplifies to negative 2 root 2 and positive 2 root 2. The square root of 8 is shown simplified here, but the math for that, in case you didn't come up with that, so the square root of 8's between 9 and 4, so the square root of 8 has to be between the square root of 4 and square root of 9, which is between 2 and 3. The difference here is 1, and the difference here is 4, so it's a lot closer to the square root of 9, so it's a lot closer to 3. So if you said about 2.9, that's fine too. So 2.8 is actually what our calculator would give us, but 2.9, I can understand why you might say that too. All right, so that then gives us 0 has our multiplicity. So notice here we have a relative minimum, and the other two have been approximated. All right. Here is a final example. You can give this one a try. All right, here's the results. So with this one, our first term is 4x cubed. So x cubed means that our right end goes to the positive infinity and our left end goes to the opposite direction, which we see here. And then with our zeros, all of our factors are different. So when there's no multiplicity in this one, we get negative 2. This one, notice it's generally easier for a lot of people to add 4x to both sides, but if you subtracted 3, remember you'd be dividing by negative 4, and a negative divided by a negative should still give you positive 3/4 for your 0. And that's approximated right there. And then this one, the same thing, I'd like adding x, which gives me 5 equals x. So my 0 of 5 there. All right, so go ahead, give your assignment a try, and have a great day.